and here is a problem from mean value theorem. In fact, we have done a similar problem already as was asked in J advanced before with cubic expression. But this problem is a bit different because here coefficient is not what we have already experienced before. Usually the problem which was usually asked is a0 plus a1 by 2 plus a2 over 3 plus a3 over 4 plus a4 over 5 plus a5 over 6. And for that the motivation is quite clear, because I would consider integral of px dx as a polynomial, let's say psi of x. Okay, so if I consider this, of course let's say 0 to x. So if I consider a0 x plus a1 x square by 2 and so on so forth till a5 as 6 over 6 plus a6. So on this, if we apply Rolle's theorem, we'll get the answers. Okay, so that is a usual problem which we have encountered, but here the coefficients is not same for all of them. So if you'll see the coefficients, what we are getting is a2 over 3 plus a2 over 5 plus a4 over 5 plus a4 over 7, and we have a0 plus a0 over 3. So you can clearly see we have terms like a0, a2, a4, and remaining term a1, a3 and a5, the odd term is absent in the system. So what to do about this? Question is px is a polynomial, and with this given information we have to prove like there is at least 1 0 of this in the interval -1 to 1. Right, so somehow I need to relate a0, a2, a4 with p of x, and clearly I can't define psi of x in this way, right? So what's the motivation? What motivation can be? The motivation is quite little bit unnatural, because we want to discard a1 term, a3 term and a5 term, so that we don't want, and we want a0, a2 and a4 into picture, right? So accordingly we'll try to invite some function such that is derivative give this kind of expression, and I can surely tell we have a root in that interval. Okay, so with that motivation, a way to kill this odd term will be probably to define px dx as an integration, because this thing is not quite unnatural. We are already used to this in the previous problem what I was discussing. So if I take px dx, clearly you can say it will give birth to a0 x, a1 x square by 2 and this, but I want to kill odd terms. So that gives a manifestation from -1 to 1 px dx. This expression will simply boil down to 2 times a0 plus a2 by 3 plus a4 over 5. So I am ready to achieve now these 3 terms, a0, a2 and a4. Now still we have to bring a1 by 2, a3 by 4 and a5 by 6. So if you closely see this, to bring a5 by 6, I need somewhere an integration of this form. So right now we succeeded in a0 by 3, a2 by 3 and a4 by 5. Now I want to bring a0, a2 by 5 and a4 by 7. Now how to go about a4 by 7 and a4 by a2 by 5? So you can clearly see the difference in index. So from 4 it's difference of 3, from 2 it's different of 3. Okay, so those kind of index we want to achieve, right? So a4 by 7 means I need to create here x4 to the power, instead of x4 I need to create x6, so that if I integrate x6 I'll get x7 by 7 kind of expression. So that motivates me to multiply px with x square dx, but again I'll give -1 to 1, and that gives me an expression 2 times a0 over 3 plus a2 over 5 plus a4 over 7. So with these two information, now I'm ready to club this, and we have half times 1 plus x square px minus 1 over 1 dx is the desired expression of the question. So that goes to a naught plus a2y3 plus a2 plus a4y5 and plus a4 over 7. Now according to the given question, this quantity is less than 0, right? So now we know this entire expression should be less than 0. Now clearly from this given expression you can see 1 plus x square is strictly positive. The worst case will be when x equal to 0. And if minus 1 to 1 integration of this expression is less than 0, it means if we have some integration function, px is a polynomial, it's nicely differentiable function. If the integration from minus 1 to 1 is less than 0, it means px must be negative at least once in this interval. Why? Because if integration is negative, so the area bounded from minus 1 to 1 is negative, numerical area. So now we can have possibilities like these possibilities we can have, where some positive area cancels some negative area and overall it gives negative answer, right? So anyway we have 1 root over a. But surprisingly there can be another possibilities, and that's what if the entire expression, the area is below this. Still we have this integration less than 0, but in this case you can clearly see there is no root of p of x. Right, so if px behave in this way, in fact it's p times 1 plus x square, let me tell, if this behaves in this way, or if p becomes less than 0 for all x between minus 1 to 1, still this will be true. Right, so we need more guardianship to show like at least 1 root is guaranteed, and here is the guardianship given. A naught is positive. Since a naught is positive, it means the value of the polynomial at x equal to 0. So p0 is a positive quantity. Now if p0 is positive, you can clearly see now this graph cannot happen, this graph can't happen. The reason being 1 plus x squared times p of x at x equal to 0 should be 1 times p of 0, and that should give me positive answer. So now the graph boils down to at x0 we must have some positive answer, and we know overall in minus 1 to 1 the numerical area should be negative. So the final expression must take this kind of shape. It means at least once to make an overall area of negative, which is basically integration essence, at least 1 root between minus 1 to 1 window, and which I would like you to give, and this was given by one of my student, the second approach, and he gave very tight window for the root. In fact, root will not lie between minus 1 to 1, but it will lie between minus 3 by root 14. 3 by root 14. Now that feels very crazy, like how someone could find this strong window as long as this condition is satisfied. That's also not too difficult, because this given relation you can package it into 14a2 plus 9a4 is less than equal to minus 35a0, right? So with that condition we can show now there is a root between this interval, because now we can take p of 3 by root 14 plus p of minus 3 by root 14 parallelly. This motivation, in fact the motivation for this window comes from this expression 9 and 14, right? So this quantity if you evaluate, this will become lesser than 9 by 98 times of 196 by 9 times a0 minus 35 a0. Okay, because the overall this summation, it will go down to, this summation goes to, which I am writing over here, 9 by 98, and please check by yourself, 196 by 9 times a0 plus 14 times a2 plus 9a4, and now this is clearly lesser than this value, so which gives less than 0, right? So now if the value of function at to output, the sum of them is negative, one of them must be negative. So at least one of the values among 3 by root 14 and minus 3 by root 14 must be negative. Since p0 is positive, so we conclude that at least one of the interval, which is minus 3 over root 14 to 0 or 3 over root 14 to 0, contains at least 1 0 px, which completes the proof. Okay, so second observation is also nice. I hope you have enjoyed the problem.